We have to find the eccentricity for the following equation of a hyperbola. X squared over 9 minus y squared over 5 is equal to 1. Before we find this algebraically, we have to understand what eccentricity does. So as you can see, by definition, eccentricity is equal to the quotient of C and A. So C precisely divided by A is equal to the eccentricity E. Now what is C and what is A? Notice that we have a hyperbola diagram drawn here. There's a center, which is right in the middle between the two vertices on the hyperbola curve. And notice A is the distance from the center to the vertex, to each vertex. That's a fixed distance. And C is a fixed distance from the center to each of the foci here, right? In this case, I show that C here is a visible distance from the center to this focus. So the eccentricity tells you what the quotient is going to look like. So the eccentricity must be greater than 1, okay? When it's equal to 1, it's going to be basically a parabola. It has to be greater than 1. Now, the reason why it's greater than 1 is that the C value will always be greater than the A value. As you can see, the C value must be greater than A in order for the eccentricity to be greater than 1. So the closer and closer the C value to the A value, the closer and closer the eccentricity is going to be to 1, right? And we cannot have E equal to 1 because it's not going to be a hyperbola. So basically what this means is that when you decrease the C in such a way that it moves closer and closer to A, you're basically bringing the focus closer and closer to the vertex here, right? So the closer the focus is to the vertex, right, the closer, the smaller the distance here, the more vertically stretched the hyperbola curve will be, right? So if the focus is closer to the vertex, basically the curve that we're going to have is going to be like this. So as you can see, it will be vertically stretched, right? Vertically stretched or horizontally squashed on both sides, right? So you would have a closer focus to the vertex, right? But I'm going to erase that so you understand what's going to happen. However, if you move the other way around, if you make the focus farther away from the vertex, if you make the focus here, what will happen is this hyperbola curve here will be stretched out, right, horizontally. So it's going to look something like this. Okay, so the focus will be spread out, and thus the horizontally stretched this hyperbola curve would be. And of course the same would apply to this side as well, right, because these two curves make up a hyperbola. Right, so you understand what happens, what actually the eccentricity does, what role it plays in the way that the shape is going to be drawn of this hyperbola. So the eccentricity is going to be greater than 1. When eccentricity is equal to 0, as you might have guessed, right? When the eccentricity is equal to 0, the focus is going to be as far away as possible from the vertex, and then this curve would become a straight line, right? But the eccentricity must be infinite for that, right? It has to be so infinitely huge that you would have a straight line instead of a curve, because ultimately you will stretch out this hyperbola curve in such a way that you're going to flatten it out to make it look like a line, right? And the focus will be infinitely away from the vertex that way. All right, so now that we understand what eccentricity does for the hyperbola, we can find out algebraically how to solve it. So we know that in the given equation of the hyperbola has this form, x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Now we know a squared goes underneath the x here, because we have a positive coefficient for the x squared here, and we have a negative coefficient for the y squared. So we know by that observation that a squared must be this one and not 5, right? Because of the positive coefficient. The positive coefficient takes the a squared underneath it, whatever it's going to be, right? So a squared is equal to 9. So a is going to be 3, right? Because you take the square root of 9, a squared is equal to 9. Then you take the square root, and a is equal to 3. Now notice a has to be positive. A must be greater than 0. and so is the b. b has to be greater than 0. So the b squared by default is 5, right? So b squared is 5. Thus, the b value is going to be the square root of that. So the b value is going to be the square root of that, right? And it has to be greater than 0, so we don't take the negative possibility into consideration, right? Because b has to be greater than 0, so we're not interested in plus and minus. We're just taking the plus when we're taking the square roots for each of these, for the a squared and the b squared. So a is equal to 3 and b is equal to radical 5, and we know the c squared can be found by using the Pythagorean theorem, which is great. It's like a squared plus b squared, right? So c is equal to what? I'm going to use a blue color here. So c is equal to, now I might as well use purple for the a, because I've been using that color there. Okay, so c squared, c is going to be the square root of the a squared plus b squared. A squared is 9, b squared is 5, right? That's here. So as a result, this is equal to radical 14. And again, c is greater than 0. It's positive, right? C is greater than 0, and c has to be greater than a, and it has to be greater than b. And as you can see, radical 14 is indeed greater than 3, and it's greater than radical 5, right? Because radical 9 is 3, and radical 5, as you can see, is definitely smaller than radical 14. So now it makes sense that the eccentricity as a result is equal to what? It's equal to the quotient of c over a, which is going to be radical 14 divided by 3. So as you can see, this is definitely greater than 1, right? Because we know to have 1, we need to have a radical 9 being divided by 3, right? Because radical 9 is 3, and 3 over 3 is precisely 1, right? So the eccentricity is definitely greater than 1, right? Because this is equal to 1. So it's definitely greater, so we're going to use that to indicate that it is indeed greater than 1. So the result is that the eccentricity is radical 14 over 3. So I hope this was useful, and now you understand the concept of eccentricity and what it does and how it shapes the hyperbola, how it changes its behavior or the way it looks. So thanks for watching, and I'll see you in the next video.